and we'll be taking Q&A session towards the end of the session. Our next speaker for the day is Dr. Valeria Kogan, who is a scientist and entrepreneur working on application of artificial intelligence and machine learning in the field of agriculture, biotechnology, and medicine. Dr. Kogan is the co-founder of Fermata and Smart Omika. Fermata is an ag-tech company focused on development of AI-based solutions for precise plant monitoring in greenhouses. I request Dr. Valeria to take over the session.
Very much. So 1 second, I'll share my screen.
Yeah. It's visible.
Perfect, thank you. Okay, great. So hello everyone. I probably would love to tell a few words about myself and the company and how we came up with the idea of creating this type of solution. So my background is actually not in agriculture, and this is pretty new industry for me because professionally I have background in applied mathematics and been working mostly in biotech and biomedicine in multiple startups leading AI development teams. And the idea of creating Fermata was pretty natural while contacting different people with the expertise in agriculture. And I realized that technologies that we develop actually for the monitoring of human health can be applied to the agriculture to control the state of the plants and help them feel better, grow better, and bring more value, more harvest to the farmers. So originally, I believe that the story of Fermata and how we built this company is a classical, very typical startup story because we have made most of mistakes that any startup does. Our original idea with the team of my friends with who we decided to create this company was that we will make a robot for the agriculture. So we realized, talking to the industry and to different people who who produce vegetables mostly in the greenhouses, we realized that there is a challenge in controlling the state of the plants. And we thought that the most smart and straightforward way to solve this challenge is actually to create a robot will move in the greenhouse, capture the images of the plant, collect the information about the climate, and then combine this all together to give recommendations to the farmer on how to proceed. So we actually even created the prototype of the system of the robot itself and started talking to different industry experts and trying to promote our solution, agree on some kind of pilots. And then we realized that this is not going to work out because robot is a very sophisticated technology. We didn't have expertise internally for developing really robust hardware, and also the necessity of making an upfront payment, which is necessary if you have a robot, right? Because it's quite expensive. In the field of agriculture, where technologies are just coming into the industry and it's very conservative, this is a huge challenge, and it's very hard to explain to the farmer who has never seen any AI in his work that, dear friend, now you have to pay several dozens of $1,000s to see in future how this kind of technologies will help you. So the key mistake that everybody does, like start developing prototype before identifying product market fit of your technology, this is like the thing that happened to us too. Oh, so you don't hear me well? Okay, I'll try to do it.
It's all good, ma'am. We're just looking out for the screen. Are you sharing the screen as in like changing the slide?
No.
Not yet, okay.
Do you hear me?
Yeah, all good, ma'am. All good, all good.
Oh, good. Thank you very much. Yeah. So, but when we developed like this prototype of the robot, we actually, and talking also to the farmers, we realized that part of technology that we have developed already with the computer vision can actually be developed into a separate product and can live its own life. So we made a strategic pivot and decided that we skip all the hardware and we do not go into hardware development, and we focus on a very tiny thing on a computer vision to control the state of the plants and give recommendations to the farmer. So this is eventually what we came up with Fermata, and now I'll tell you a little bit about the product and the technology that is behind it. So what's the challenge? The challenge is that you can see this is a typical greenhouse. This in particular is medical cannabis, a project that we are doing in Israel. So this is how the greenhouse looks like. So you can see here zones where people can go and control the plants, but still there are zones which people do not even observe. And this is very important problem, because any of these plants that you see on the image can become a source of the disease. And then if you do not identify disease fast enough, it will grow, it will contaminate the neighboring plants, and eventually what happens from time to time, the whole harvest can be lost because of the diseases spread in the greenhouse. So currently all of this is controlled manually, and the efficiency of the disease distribution prevention in the greenhouses is low, because it's very hard to observe and control every single plant. So the loss of the harvest, which is on average 40%, depending on the type of plant, depending on the region, due to diseases, this is what actually happens in the greenhouses. And ecologically, this is also a very important problem, because this is one of the main sources of the food waste on the planet. And also financially, this is quite an issue, because only in greenhouses, we're not even talking right now about the open fields, almost $4 billion is lost annually of the harvest because of the diseases that were not prevented in the greenhouse. And there are two main reasons for that. First of all, is that all the monitoring is done manually. So there is just a person in the greenhouse who is called a scouter, and who just his work is just to go around the greenhouse, look at every plant, and see if there is some kind of challenge or some problem with the plant, and then call an agronomist who can visually understand what exactly is going on with the plants. And of course, if we're talking about large greenhouses and such crops as tomatoes and cucumbers, which grow really like jungles, this is not a very efficient approach to controlling the state of the plants. The second problem with the humans who are working in the greenhouse is that they themselves become the source of contamination. Because even though in every greenhouse there are standards, so you have to wash your hands, change the clothes. Anyway, there is always a risk that on your clothes, or just because you're because of your body, you will bring bacteria or viruses to the greenhouse and contaminate the plants. So this is how you come naturally to the idea that maybe reducing the involvement of people in this type of work might lead to reduction of the harvest loss due to diseases. So to address this challenge, we have developed the solution, which is AI-based, and that combines agronomist experience and computer vision. So what do? We create a system that controls the states of the plant. So these are the cameras which you can see on the image, which we install in the greenhouse, and to collect the images of every single plant. So this is the camera which is spinning around and making photos of the plant several times a day. So then every image that was collected in the greenhouse is sent to our AI system, which automatically analyzes these images and identifies what's going on with the plant. And if we see that there is some issue with the image, with the plant, then we inform the farmer with what we have identified. So this is the basic concept. Now a little bit about the details. So this is how our software looks like. So this is a dashboard. The access to this dashboard gets the responsible person in the greenhouse. This can be either agronomist or a grower. It depends also on type of plant, on the size of the facility where we are working. So if there are software developers here, you can see that this is like a Kanban board. So it was inspired by Jira and all the tools that we are working in. So we can see here that there are tickets that we assign to every issue that we have identified in the greenhouse, and the grower can open the ticket and see what exactly did we find in every location of the greenhouse. So we have our app available for the desktop and for the mobile. So here you can see how the ticket looks inside. So we have an image of the plant that we have captured. And here, this red square, actually, this is selected diseased plant. So we can see here that this is for cannabis, this is a bud rot infection. So it was identified here. And we can see where exactly on the map in greenhouse was identified this diseased plant. So the grower can see this image, can see the location, go and check if indeed this identification was correct. So he doesn't need Scouter anymore because we do it automatically. And for example, this image that you see right now, this is a real case, real life case where we managed to identify this bud rot infection in the greenhouse. There are thousands of these buds growing in the greenhouse, and we identified the first 2 buds which were infected with this type of disease. So, and we managed to alert the greenhouse really premature with these buds that needs to be removed because they can spread the disease really rapidly, and this made our clients really happy. So there are different features in our app, like for example, retrospective. So you can open every image, see how exactly the disease was developed. And the goal for that is to make it possible for the agronomist to make sure remotely that what we have identified as a disease is indeed correct, and not to spend too much time on going to the greenhouse, identifying the specific spot and controlling the state of the plant. So this was about the app and how it works when it's up and running to the client. The other important thing that we realized is that the solution that we develop needs to be plug and play. And if there are some challenges with hardware and we request too much from the client, this is also a huge challenge for scaling our product. So eventually we came up with a solution where we do not install any cameras ourselves. So this is out of box solution. So we do not have any installation teams in different countries. We send the client everything already pre-prepared, like all the cameras, all the wires, all the instructions. So everything is ready already in the box, and it takes them just a few hours to settle the system and get it up and running in the greenhouse. So we have already, the company is 1.5 years old. As I mentioned in the beginning, it took us some time to do this pivot, but eventually with the project that we have performed already by this moment on different types of plant, we have shown that we're capable of reducing the time of monitoring that is done manually in greenhouse by up to 50% of time. So this is 50% of savings for the labor in the greenhouse. And also we show that we can save up to 30% of the lost crop in the greenhouse due to diseases. I saw the question here. I don't see all the questions immediately about the coverage made by one camera. This depends on type of greenhouse we're working with. So the higher ceilings, the more area we can cover. And in the classical greenhouse, this is around 400 square meters per camera. So what about the competition? So who already does these things on the market, and why do we see that we have a large potential? So for years, there was an idea that we need to predict what's going on with the plants in greenhouse too. So, and how can we do it? How can we estimate the state of the plants? And the normal approach was, let's collect some external information about the plants, like the climate that surrounds this plant. Let's collect information about temperature, humidity, I don't know, other factors, and then build models to predict the state of the plants. But the recent trend is not to use some external data, but to collect data, the plant data, directly from the crop, so that we visually control this crop or attach some sensors directly to the crop and ask him, how do you feel? And he just answers us. So this is the new approach to controlling plants in the greenhouse. But the main challenge here is how to build your hardware the way that this is a universal solution. And these companies that are in this corner, they actually do the similar thing that we do, but they have really very complicated hardware that is dedicated to some particular type of crop or particular type of plant. So our approach was to make a scalable solution as possible, both on software and on hardware side. So on hardware side, we're not attached to any type of greenhouse. We have experience working with classical greenhouses, indoor facilities. You might know that this is a huge trend worldwide now to use commercial buildings to create greenhouses and grow plants inside them. So this is a completely different construction, and we're experienced in working with that. We also have experience in working with vertical farms, which is also a huge trend right now. And from the software perspective, we have built our AI and the whole pipeline of how we train our networks and how we deploy them to make our solution really scalable. So we have experience in working with, as I mentioned, medical cannabis, leafy greens like lettuce, basil, and also with classical vegetables like tomatoes and cucumbers. And our solution, our AI, is very simple to be trained and scaled from one type of crop to another type of crop, from one task in particular type of crop to another task. So in general, this all helped us to create a really scalable and fastly scalable solution. We are not limited just by disease detection. This is the thing we have started with, but try not to limit ourselves with that and explore different opportunities. So also we have built our AI pipeline to make it possible to solve different tasks and be prepared for different questions and challenges that are important in the agriculture. So we have neural networks that we apply for quantification tasks. These are like tasks where we need to quantify number of fruits, for example, on the image, or number of leaves on the image. We have a number of neural networks working with classification tasks, and disease detection is, of course, one of the classification tasks when we need to identify on the image whether the plant is healthy or unhealthy. But this can be other tasks too, like ripeness of the fruit, for example, if we need to identify whether the fruit is already ripe or not yet, and then give some specific recommendations to the farmer. Well, we also have technologies for the size estimation, like when we need to observe the growth of the leaf and to identify the speed of this growth. And also we are working right now on weight estimation tasks, also to analyze and predict the weight, for example, of a fruit on the image, or like a tomato, or the weight of the bush of lettuce, for example. So regarding the market potential for our products, currently we are targeting, as I mentioned, greenhouse market. This is 500,000 hectares globally. And the most interesting markets for us right now are United States, Spain, and Netherlands, because they are the largest players on this market. And regarding the products, so currently we have two products. One is B2C product, as we call it, where we work directly with the farms. And here, this is mostly about disease detection. So we send the box with all the hardware, greenhouse install this hardware. We do not request any upfront payment for this hardware. And then we start charging them with annual subscription, which covers both software and hardware. And the goal of this product is to reduce crop losses and reduce the amount of time that the workers spend on the monitoring of plants. The price of subscription is calculated based on the value that we bring to the farmer, so we can estimate the amount of money that we help to save to particular grower annually, and then we charge them with 30% of the potential savings that they get with installation of Fermata solution. The other approach that we are focused on right now very strongly, and we believe that this can actually generate us the larger cash flow, is a B2B product. The approach here is the following. There are a lot of companies that develop solutions for greenhouse, which are hardware solutions. Like, let's take, for example, lighting companies. What do they do? What does Philips do, or any other large players? They sell their lamps, and that's it. So they just get the money for the hardware, and their relationship with the farmer ends at this point. And all these guys who do lighting, irrigation, fertilizers, or even manufacture the greenhouses themselves, they are all interested into switching from just selling hardware to some kind of recurring revenue models. This means that there should be services attached to their hardware, and based on these services, they can annually or monthly charge the farmer for some additional value that they bring to him. And here Fermata comes. So we work with these companies to add computer vision to their solutions. Like, again, if we're talking about lighting companies, that means that we install not just the light, not just the lamps, but also several cameras in the greenhouse. And the goal of the cameras in this case is not just identification of diseases, but identification of the state of the plants from the perspective of lighting. Like, what do we see on the plant? What does it actually need? Does it need more light? Does it need the spectrum to be changed to get more harvest? And we answer all these questions and develop solutions together with our partner to make a mutual product. And then for him, for the partner, lighting company or fertilizer company, to market it to the end user, who is the grower, to help him make more money and create more harvest from his plants. So this is our approach to help these hardware manufacturers to switch to recurring revenue model with the additional services that are created by Fermata. So through this time, we have managed to build a team where we have 10 people, which are most software development guys. We do not do the hardware ourselves, so all this headache with the cameras is not right now our headache. So we have a partner who is a video surveillance company, which does video surveillance for security. It's a large company in Europe, and we partner with them, and they prepare all the hardware for us, send it to our clients, and we can stay focused just on software development. So these are 10 people focused on software development, and currently we are very much growing our business development zone, because we have already conducted a number of commercial projects where we see the value and that our product is working, and are really ready to scale our solution right now. So a few words about the future plans. So we are working on fundraising for global expansion of our product. So we are achieving EU and US markets right now. So that's what we're doing, and we are open to any type of collaborations outside of this region. So we are also expanding our R&D team, business development team. And regarding the product, so a very important challenge for us right now is to show how exactly we can switch from just greenhouses to the open fields, because open fields market is much larger than greenhouses, and there are much more interesting challenges in there. So we are working tightly with our team to bridge this gap between greenhouses and open fields, and find the perfect way to collect the images and apply computer vision to solving open field tasks. So this is basically it. Also, all the contacts are available, and I will be happy to get in touch with anyone who is interested to work together and find some mutual interests with Fermata. Thank you very much.
Thank you, Dr. Valeria. Thank you for your presentation. Now we move on to the next speaker. Our next speaker is Mr. K.A. Gopalkrishnan. He is the co-founder of Grainworks Agri-Tech, a startup working in the domain of precision farming. They use AI and IoT-enabled tools to provide farmers with the microclimatic condition of the farms, real-time weather insights, and future weather predictions to help them make timely decisions. Mr. Gopalkrishnan is also an incubatee under the RKUI Raftar program, cohort 3, and a grantee under the program. I request Mr. Gopalkrishnan to take over the session.
Thank you, Zinat, and a very good afternoon to all the participants. Let me know if my screen is visible.
It's visible. Can you please make it full screen?
So
Yeah,
today's topic is about data analytics and all about disruption in the field of agri and technology. So let's look at the big picture. Why is data going to play a prevalent role in the field of agriculture? The statistics are right in front of you. There is going to be a 50% increase in the demand of food in the next 3 decades. In absolute numbers, that means we need to have more than 3 million mouths that needs to be fed. Also, there is going to be a 12% increase in the number of people who are going to be living in the cities. And over a period of time, what has been happening is the number of people who have been in the field of agriculture in terms of either workers, laborers, have been dwindling down. So what you see is a mismatch in terms of what the requirement is vis-a-vis what the infra is currently. So in terms of defining the food security over the next coming years, technology has to be leveraged and it will be playing a crucial role. Now, this is just giving you a broad perspective about the entire agri value chain and where data and data analytics is going to be playing a role. Each one of these points or interceptions have excellent use cases where technology can be intercept and it can come out with great solutions. So all the way from your seed to the table, whether it is the farm to fork model or like, beat se bazaar tak, there are opportunities of technology and data interception that would take place. If you look at this segment, which is the farm segment, farm management segment, where you're looking at inputs, production, harvesting, there are opportunities of increasing the yield, improving resource utilization. All of this will happen with the utilization of data, data analytics, and technology. On the other side of things, where you're talking about supply chain, there are instances of food traceability that are coming into question. You're looking at transparency, you're looking at better traceability. So there are great opportunities for great plug points for each one of these where technology can play a pivotal role. Now, this is just a quick overview about what data to data analytics looks like. So the main important thing is how do we capture the primary data from? Primary data can be data from your IoT devices, from your automatic weather stations, whether it's your images, satellite data. All this can be taken or captured. The second part of it is how do you store this data? Where do you store? Where is the cloud? Whether you got the Amazon Web Services, Microsoft Azure, and so on. Then how do you transform this data? Transformation of data is the key area where you take the raw data, convert it into some tangible format so that the end user is able to make use of it. And finally, the data marketing. Who is your use case? Who are your customers that you're building your solutions for? That needs to be clearly defined for the data analytics to be presented. Let's look at some of the potential use cases which are driving data-driven use cases in the field of agri and technology. The first space is where we are located, which is under the water and crop management. What I'll do is I'll go in depth about what Grainworks does. Going to the next one, there are opportunities for robos that are able to detect in a very selective way what is the actual crop versus what is the weed and it is able to measure things like row to row spacing in a given open field cultivation, what is the plant to plant spacing, and in a very systematic way it is able to kind of detect the weeds and eliminate them. Then you have your unmanned vehicles, your drones that are coming into play, where your primary data is captured either through the camera. Camera can be an hyperspectral camera, a multispectral camera. The data is taken based on the primary data that we get through the images. We can actually understand where the stress areas are. Stress areas can be irrigation deficiencies, some kind of micronutrient deficiency, and specific areas can be targeted in terms of either the fertilizer or the pesticide spraying that could happen. Then the next use cases of image processing is happening in terms of pest detection and in crop quality detection. So here your primary data is taken or given by the farmers. It comes into your cloud. Then you reference it against your multiple data sets that you have created. You can use multiple neural networks, CNN, ANN, try to juxtapose this data and then come with an outcome, that this is the data that has been fed by the farmer, reference it against the thousands of data that you already have, and then provide an outcome to the farmer saying, hey, is your leaf healthy or not? Is it lacking in deficiency? So the end customer is able to use such technology to kind of leverage and try to get a solution in terms of whether his leaf is healthy or not. Then you also have opportunities for chatbots. So the farmer can just type in what is the weather in my farm, and all the information regarding his farm is provided to him on a handheld device. Similarly, for device prediction and forecasting, this is on the supply chain side of things. Startups are now trying to get historical data in terms of how the entire demand looks like on their end, and they are able to hedge this accordingly and buy produce from different parts of India or even around the world. Now you have the price prediction models that are being built by the government. You have the ENAM that is already there, where you go to a mandi and that specific day the produce is entered, the grade type is entered, the amount that is paid to the farmer is entered, and this data is coming from multiple points across India. So slowly data sets are being developed, and what it will help is once the data is built over a period of time, like how we have for the financial world, we can help in better predictions. Better models can be utilized over a period of time. So this slide actually just says that this is the beginning of where data is being captured, data is being stored, models are being built, and better results are going to be provided from here on. So it's just the beginning of the data analytics in the field of agriculture. Now, what I'll play is a quick video about what Grainworks is all about.
Weather are the most important factors that defines the success of a crop. Yet there is very little knowledge and data provided to the farmers to understand the exact needs of their crop. Grainworks is an agri-tech company specializing in developing technology solutions based on local scientifically validated agronomic data, synchronized with hardware tools in a cost-effective manner. This enables farmers to make decisions based on data. With Grainworks' Internet of Things enabled platform, we collect real-time microclimatic data from your farm, including crop type, location, elevation, and soil type, which is then analyzed using our unique algorithms. This results in accurate predictions for the farmers, thereby increasing the yield, optimizing water utilization, and mitigating weather and pest-related risks. This data can be accessed anytime and anywhere through our mobile and web application. At Grainworks, we aim to bring predictability to farming.
Excellent. That was just a quick overview about Grainworks, what is the type of solution and what is the problem that we are trying to solve. So this slide just runs through the problem that we are trying to mitigate. So water is a very critical resource, and in many areas across the globe, water is becoming a stressful resource already. At a macro level, when you look at India, it has 4% of the world's freshwater resources. Out of this, 60% is actually utilized in the field of agriculture, and over the last 1 decade, there has been a 20% reduction in the per capita availability of water. Now, deep diving into the micro level, that is from an angle of our customers or the farmers that we work with, farmers are struggling with weather uncertainties, especially erratic rainfall. Second, there is a lack of data-driven decisions that a farmer takes, especially for irrigation. Third is there is a high exploitation of groundwater resources. So what do we do actually in terms of this data-driven solution? What we do is point number one is taken local parameters such as temperature, pressure, humidity, wind speed, rainfall. All of this is taken from the farm directly. So we have things like geofencing, so we get to know the exact perimeters and the exact area of the farmer. We also take in inputs such as where is he drawing the water. We also ask him for details such as what is his drip emitter rate. So whether it is 4 liter per hour, 6 liter per hour, and all of this. So we gather all this primary data from the farmer's field. Now, just gathering primary data doesn't actually solve the problem, right? So where does data analytics come in? This is the role of data where we are taking the primary data. The second part of it is where we are analyzing this. So once we get all this primary data, we are able to solve for two things. One is irrigation management. So what we deliver as a service to a farmer is how do you quantify irrigation for a given type of a crop in a geographical location based on the soil type that you're actually having. So based on the stage of your crop, based on the phase of your crop, we actually tell them how many liters of water is needed, either in totality or even per plant if he's using drip lines. The second thing that we tell a farmer is in terms of disease management. So when I say disease management, anything that is related to either fungal or bacterial disease, since we are getting all this primary data from his farm, which is very specific to his farm, we are also helping in terms of predictive spraying so that he can mitigate his diseases. Third, how is this data actually presented to the farmer, right? It has to be presented in a tangible format, So what we have is a simple tool on the Google Play Store where he can look at all these data sets on an active basis. Notifications are sent out in a timely basis. So he can see all this information at the palm of his hand and then take steps accordingly. Now, let us go through some of the case studies that we have done at a macro level and also at a micro level as to how data is trying to solve issues on the ground level. So our first case study is where we looked at a tomato, almost similar soil type, soil texture grown in Andhra Pradesh and in Maharashtra. Now, what we noticed was the temperatures in Andhra Pradesh were consistently higher compared to the temperatures in Maharashtra. What would normally, in terms of like a thinking, a rudimentary thinking is, you would understand that you might think that the amount of water that is required for the field in Andhra Pradesh is more than the field in Maharashtra. However, what we noticed was the irrigation requirement in terms of volume in Maharashtra was greater than in terms of what is the water requirement for the same plot of land in Andhra Pradesh. What we noticed was the wind speed plays a very crucial role in actually evapotranspiration. So the wind speeds in Maharashtra were much higher as compared to in Andhra Pradesh. Hence, the requirement of water in for the same crop type seed that was grown in AP versus Maharashtra was much higher. So, what is the message that I want to convey here? Data is the one that led us to this conclusion that hey, this was the factor because of which water requirement was more in this state vis-a-vis this. So today, water is a free commodity. But just assume if you have to put a value for water, which is a better area for you to actually grow a crop, one can start defining that at a macro level. Now let us look at another case study. This is at a micro level where we are working with grapes farmers in a certain region. So the situation was one, it's a drought prone area. Second, their irrigation is based on the touch and feel method. So in many cases, like 99% of the cases, they never look at data at all. It's what what they've always been doing that they follow, and they also pass it on to the next generation. Also, it was a large acreage, and there was a disconnect between the farm manager and all the resources on the ground. What helped here is once they installed the IoT device on the ground, they were able to quantify what the water loss was from the pruning stage, which was the foundation pruning, all the way till the fruit pruning, then from the fruit pruning, berry development, berry growth till the harvesting stage. So across the entire cycle of the grapes, they were able to understand the water loss that was happening. Number one. Second is they also were able to get specific insights on what is the per plant water requirement that was needed and when it is needed. So two questions are being answered for irrigation. How much water is needed and when it is needed, right? So through the entire, one is the hardware device, and then coming to the handheld application that they were able to get, very specific insights on the per plant requirement. Third, what we noticed was habits don't change overnight. It took us some time for us to convince, that they were using their practices. They were almost irrigating every 4 times for a given phase of crop, every fourth day that they were irrigating. Slowly, they changed to what we were actually telling them, which was irrigate only like every 6 days. So 2 days additionally were being added on. Since that happened, what we noticed that was the berry size and also the bricks content were almost comparable to what it was before. Now they have adopted the practices that we are actually propagating, and that has led in irrigation reduction of up to 40% for their given farm. Second is they're having data-based irrigation now. So all this data is being stored in the backend. They are able to access it. They are able to access the last 1 year historical data as to how the trends are looking. When was the time that I had the maximum lux or watts per meter square in my farm, which is the time that there might be sunburn in my farm. All this data they are able to analyze because it is presented to them on a web dashboard. We also have certain features such as satellite that we are working on so that they can try to understand stress from a macro level in their farm. Stress means it can either be pest related stress or disease or irrigation related stress, so that they can go to that specific farm plot and understand what the issues are happening. Let us look at a third case study. This is in terms of how the microclimatic conditions that we are taking from the farm is actually leading to disease detection. So this was a farmer growing tomato. Because we are able to actively monitor the farm variables, whether it is humidity, whether it is rainfall, we are also able to mitigate any type of bacterial or fungal diseases that might occur in the farm. So an analogy is nowadays you have these smart devices that people wear on their hands. So it is monitoring things like heartbeat. It can monitor your body temperature and it sends an alarm the moment it crosses a certain threshold. The same analogy or the same techniques can be utilized in the field of agriculture. So we are actively monitoring certain thresholds that the farm area might cross. It can be, humidity can be 90%. There might be a sprout of rainfall about 2 mm and plus. Hence, the probability of mildew is much higher. Such bacterial and fungal diseases notifications are being provided so that farmers can take preventive measures before the entire thing can affect your entire farm. So this is where data was taken from the IoT sensors and so on. Then we have the algorithms that actually crunch, and the output is in terms of that there is going to be a probability of a certain disease in your farm. In terms of analytics, again, your farmer is able to visualize all this data. Say, for example, this farmer has got notification saying there is a higher probability of fusarium wilt in your farm. Hence, for fusarium wilt, what is the symptoms? What are the potential treatments? Whether it is a chemical treatment that you want to take, a biological treatment. All of these measures can be provided using data analytics and technology. So where does it all lead to, right? How does data analytics technology play an important role? So what we believe and what we have seen is the data needs to be very specific to the farmers and the farm that you are working for. So, going a couple of slides back, one needs to clearly define who's the customer that you're targeting to. We had one of our other members talking about satellite data and how they are giving the services to the banks. In our case, we are trying to give the services to the farmers. When we're trying to give the services to the farmers, he or she needs data and solutions very specific to their farm coordinates. Otherwise, high level data is of no use to them. Second is it has to be very crop specific and take into considerations such as what is the soil type, what is the soil texture. All those parameters need to be taken into consideration. Third, we also see for the dissemination of data, data analytics, and so on, it needs to be provided in a local language. In a case like India, there is demographic dispersion every 250 kilometers that you travel. Data needs to be one, tangible. Second, it needs to be provided in a format that the end user is able to understand, which is simplicity, and it needs to get the message across. So these are the three main considerations that we keep in our mind before we present the data to the end user. So all these insights and indicators help the farmers approach agriculture in a data-driven manner, and that's the goal that we want to go towards. There are also challenges with technology. So one is what we see is large quantities of data is required for data modeling actually. So whether it is your image-based pest detection, the model only improves as and when you have large set of data quality so that your reference image and the neural networks that you want to work on will get more solidified. So what we see that it's the beginning. Farmers are going to adopt this. They're going to get the images. They're going to scan them. They're going to send them, and it is only going to improve the data set so that the outcome in terms of what is being provided to the farmer, that hey, there is a magnesium deficiency and so on, will only get improved over a period of time. In terms of large quantities of data, we also have a case where we tell the farmer in terms of irrigation prediction. So which means if you're growing, say, a crop tomato, if it is in the developmental stage right now, we also give you a 2-week forecasting as to what your water requirement is going to be. The reason we were able to do that is we were able to work with a couple of institutions such as ISRO and so on, collect the historical data, and based on historical data, do some forecasting as to how the water loss is going to be looking in your farm. So such data sets need to be built and will be required over a period of time. Second is the quality of data also that you take once you are building that algorithm or metrics need to be of a good quality. So what we noticed is there are weather stations across India. We could have easily taken data from that and then provided to the farmer. But what we noticed was, one, some of those weather stations were not working. Second is the responsibility in terms of the operations and maintenance and how to get data was not defined properly. Third is it is not farm specific. So for our customers, when we were trying to get them data based on, get them the solutions based on that data, there was too much fluctuations or there was too much variations in the outcome. That was the reason why we felt that IoT devices on ground are very important so that the quality of data that you get is very good. Third, initial cost of technology is high. So this is the hockey stick method. The technology at the initial point is going to be high. Then you're going to have the technology adoption curve. As and when the technology gets propagated over a function of volumes, the cost is going to get reduced. Number fourth is regarding policy and governance. While our core problem that we worked was towards irrigation management, we also noted was water is free as a commodity in India. So which means if water is available to a farmer, he doesn't really value it in terms of a rupee or a commodity compared to like an input that he might be using. So he really quantifies, how much pesticides he's buying, fertilizers he's buying, so on and so forth. But in terms of water utilization, it isn't being governed in that angle. Hence, policy and governance is also going to play an equally important role. You might have noted the recent changes that have come in the drone adoption or the drone utilization. There are new policies that have come out in the last 2 weeks, which is excellent in terms of the entire policy is much more easier for adoption of drones, not only in the field of agriculture but other spaces too. The fifth point is capacity building. for any technology to be disseminated at the ground level, and especially when I take ground level, I'm talking about the farmers who are customers. You need to teach them. You need to teach them what are the use cases, how is it going to benefit them, what are the end goals that they'll be reaching. Is this going to lead to an increase in the yield? Is there going to be an improvement in the productivity? The capacity building does take time, hence the technology dissemination also will take an appropriate time. So these are some of the challenges that we feel are also there in terms of the adoption of technology. So finally, I'd like to leave with this slide that there are great opportunities across the agri value chain in the utilization of data, in the utilization of technology building, but the idea lies in the using of it. Uh, this is a quick overview of our team. We are a bunch of engineers, ex-product developers, uh, full stack engineers, data scientists. Also have folks from the field of agriculture who are the subject matter experts. So we have folks from a different domain coming together to solve the problem. And one of our main mission is how do you develop in India? How do you make in India for the world? So we have developed both the hardware part of it. We also have an entire SaaS-based platform which takes into consideration about the crop management as well as for the agri businesses that are there. Do reach out to us. Our email is hello@grainworks.com, and looking forward to the questions from you all.
Thank you very much for your answer. All three of speakers today has brought in their own perspective to the today's topic. So probably we'll start with Valeria because the product or the applications are of a different, what you say, different, serves a different purpose. So there is the first and foremost important question. Uh, are you planning to work in outdoor also? Now we are working on poly houses, indoor and a controlled environment. Do you have any plans in near future? How you are going to go about it?
Yes, this is a very important questions like for ourselves too. So we are challenging currently different approaches to do that. The main question, of course, is how to capture the images when you're working outside. Drones is very important and popular trend also, what everybody's working with. I'm not a large expert in this zone, but I have my internal skepticism based on the work that we have done by now, because drones are either really cheap and you can use them easily to collect images, but the challenge with these cheap drones is that their battery lifespan is really low, and also they can be destroyed by the wind, they can be easily lost. So these kind of cheap drones are not really a good option. If we're talking about some more robust solutions like converter plants, they're extremely expensive. So here there is no perfect solution. What we're trying right now is setting up cameras on the machines that are used in greenhouse in the open field. So everything that is moving already in the open fields, we are trying to test it without introducing new hardware to collect the images. Before COVID, we had negotiations with John Deere for this project, which is currently a bit stuck because of pandemic. But this is the direction I believe will be moving in the future.
Okay, thank you for that. The next question is, can the software be used standalone? You have both hardware as well as software, right?
Yeah.
Can the technology developed through software can we use it as a standalone application, or it need to be used along with only hardware?
No. Of course, it can be used as a standalone application. This is the goal for us, to stay as much in software as possible, because we're a startup. Well, startups always have a limited amount of sources, like both money and people. So we need to stay focused. And our focus is, of course, in the software. So if there is a partner who has already hardware that is capable for collecting images with good enough quality for us, then we'll definitely move forward. We have partnership with one of Israeli startups that does lighting with already pre-installed cameras, and this is for us the perfect partner to provide our technology.
Okay, are you done? Okay, thank you. Sorry. So the next, the follow-up question is if it can be used by other people. So probably would be we'll check with our, we have, because manage as an organization is working with more than 250 startups. So there are quite a few of them are using different types of devices. We'll see that any cross-border linkages can happen to manage to our startups. We'll move to the next speaker and we'll come back to you after probably a couple of questions addressed by them. So we'll be starting with our Satsur Rashmit sir. The question. So most of the farmers in our India and our Indian with very smaller land holdings.
Yeah.
So how does the satellite imagery work in their case? Can you please explain how does it work for a small, because the area of land holding is very small when compared to many other countries.
See,
so how does it help small and marginal farmers in terms of both in terms of satellite imagery, at the same time in terms of as a product per se? When you link with the banks, how do you see a small and marginal farmer as a customer? It's a combined question per se, so that you can address both together. Please.
Okay, sure. I'll take the first question, as in how we address the smallholder farmer who has a land holding less than an acre. Frankly, it depends on the spatial resolution of the data, meaning the satellite data that you're using, as in 1 pixel, how much it represents on the ground. So if you have the data that we use, which is openly available, it's 10-meter resolution, right? So technically, the information that you can get for a less than an acre farm, it's good enough to derive analytics. So I would say it depends on, first of all, the spatial resolution of the data and the quality of the data. So we rely on the open source data. That's where it helps us to identify those smallholder farmers which have less than an acre per se. It also helps us to also identify if there is some kind of mixed cropping, because as I said, we are not just using the satellite data, but also it's kind of sometimes our clients do require more granular information as well. That's where we also integrate that information using drone data analytics, right? That's one. Your second question was that, can you please repeat your second question?
Sure. So the idea was basically, so most of the time, small and marginal farmers has problem accessing the finances. Because
Okay.
Land holding, yes, please.
Okay. See, what we're trying to do here is, first of all, we are B2B company, meaning B2B, B2C, as in we directly do not interact with the farmer as such. But what we are trying to do is we are using the technology that we have built, we are trying to increase the transparency for our customer, whether it's kind of bank, insurance, reinsurance, even with the government bodies. It's not just we are working with the banks, insurance, we're also working with the government bodies as well. So using our technology, we're trying to increase the transparency, what's happening on the ground, making it more robust. That way, we are trying to improve the system here that eventually will help the farmers at the end. As I showed you one of the case study, right, where one particular farmer was able to get the loan, right, even though she didn't have the credit history. But based on, that's the beauty of satellite data. You can go back in the history and you can see what kind of crop it was, what was the performance of that, whether there was some kind of damage or not. So based on that, you're kind of creating a proxy using the historical data, based on which you're kind of trying to lend them for the current season. So this way, it's both ways, as in you're using the technology to increase the transparency in the system, as which can eventually benefit the farmers at the end.
Yes, sir. I completely understand the business model, and I mean, you are enabling through your technology, you are enabling more and more farmers will be financially inclusive with the banking or non-banking credit system.
Yes.
Yes, sir. Yes. So, how do you think? I mean, the scope goes, sir? Because the number of players, when compared to earlier, credit cards also increasing. So, where do you see in the future? What percent by what time? How many years? What percentage they are covered now through these kind of technologies, so that more and more people can get into credit cycle.
Kaushik, you were breaking actually, as in for last 2-3 seconds.
Sorry. I'll repeat my question, sir. Hope let me switch off my video. The basic question was, so where do you see this sector heading? Because more and more farmers require help from the banks because of increasing cost of inputs and delay in getting their produce money, whatever the produce they are producing, it is taking time also. So where do you think the sector is heading with the intervention of banks?
Okay. See, we have a technology now. It has to be implemented in the sector first of all, and some of the banks, they are tech savvy. They are kind of using the technology. It's not just about our technology that I'm talking about. I'm talking about multiple technology, and that's where the disruption is happening now. But it will take some time to happen. And as you said, technology will enable the better risk management for them. When I say risk management, it's not just for the banks, also for the end customer. Meaning, if somebody is taking a loan, uh, there's a transparency in the system whether the loan, whether the particular person is going to be default or not, right? If there is a default, there should be a genuine reason for that. It should not be a willful farm, but also to identify different areas where the financial inclusion was not there, meaning as in where the bank was not catering to the number of farmers. So technically, you are using the technology, you are enabling those farmers also to become eligible to get the loan, have easy access to the money, uh, and creating the credit history for them, right? This way, they are also getting help, and that's where slowly the whole agriculture market, this tech sector is also moving as well as, but it will take some time because as I said, there's some kind of still the data asymmetry is still there, but eventually uh, also now government are also taking initiative to creating the digital boundary for each and every farm, right? That will also help to have a proper record for each and every farm and generate the analytics which can be directly usable by the banks, by the system itself, right? So that way, it will take some time, but yeah, I see that in next 3 to 4 years or 5 years, this system kind of becoming more robust, and that way it will also eventually help the farmers in the end.
Okay, thank you, sir. We'll move to the Gopal and get back to you, sir. Gopal, the one pertinent question is, see, government has almost all the data. Whether it can be different, it can be Government of India, Agriculture Department, Weather Department, all those things. So, and most of the time, this is open source in the sense the moment you ask them, they would be ready to provide in most cases. So, how do you think, especially the startups who lacks data, who work data analytics requires a lot of data. If you don't have enough data, so you cannot come out with the solution or a prediction which can help the farmers. So how do you connect this pool of data to what you are looking at the solution you're going to arrive? So can you please throw a light upon that, because we've been working on this the past 2-3 years.
Yeah, so I think government is sitting with a huge repository of data, and in today's world, data is the new oil, as they say. So it is, how do you utilize this data so that your end customers or consumers, the solution that you're trying to get them is presented. Say, for example, we were trying to specifically work on the irrigation management side of things. So we needed data all the way from your weather parameters, your weather conditions, all the way to your soil type and structure that is. So we had to approach different organizations. When you're trying to solve a solution as a whole, it's almost like trying to solve a puzzle. So for example, all the soil data is there with NBSSLUP, which is the National Bureau of Soil Sciences. So they have, if you go to Maharashtra, what your soil texture is going to be at a district level, at a taluk is available with them. So there is an organization that has got a list of all of that data. Second, IMD has got the current data as well as historical data, right? So everything related to your automatic versions, everything related to your weather conditions, weather parameters, temperature, humidity, pressure, and so on and so forth. That is there with the Indian Meteorological Department. So they have all the data sets related to only weather conditions. Now, then you have specific institutes, like you have the Research Institute in Shimla for potato. You have the Indian Institute of Horticultural Research in Hesraghatta in Bangalore, which does crop specific information, crop stage, the phenological stage, type, the root depth, and all of that. So you get to know the crop data from them, right? Then you try to package all these three ingredients together. You have your soil texture from some other institution, then you have your weather data from a different institution, then you have the entire working of a given crop from a third institution, right? You would have to liaise with some of these stakeholders to try and derive what the end product is going to be. So for our case, we had to kind of go through this stage in terms of talking with them, asking for the region of India. So this is how we approached the entire scenario.
Okay, thank you. Thank you very much, Gopal, for your detailed explanation. And now we will open our forum to all our participants today. We'll unmute one by one, depending upon the questions there. Anand Prakash, can you hear us?
Hello.
Yes, sir. Yes, sir. Please.
Yeah, just I want to ask the question, ma'am. Do you have any solution to count a number of fruit in the tree? Like
Yeah.
mango? Yeah.
So technically, yes, we have this experience. The main question here is how to collect images. So what is the best way if we have like thousands of trees, we need to somehow collect automatically images of these trees, and this is the main question. So I think that this should be like discussed in details. What is the task and what is the best solution for that? But if we have these images, there is no challenge for us to make these computations.
How you get these images with the help of your camera? Yeah, we have to provide these images.
Yeah, exactly. So we can brainstorm together what will be the best way to collect them.
Okay. Thank you. Thank you, ma'am.
All the participants are requested to raise their hand. So there is a symbol. You can see that you can raise your hand if you want to ask a question. Thank you for that. Then we'll go to Ashwini Kulkarni.
Yeah, good morning. My questions would be for Rashmi ji. Basically, when we talk about satellite data, capturing, I understand that this query was well addressed. However, please throw light on more points where in India, the farmlands are extremely in small size, one and two. They are mixed of in terms of crop and in terms of the ownership as well. So, for instance, how does this activity of capturing certain section or certain crop or certain soil is concerned, and then giving insights on all these products? Because as Valeria rightly said, that because of this climate, the drones would either fly off from the focus or it could be damaged. But in our scenario, because in abroad it's like hectares and hectares of big farmlands where satellite imagery is possible. So how do we address this particular point here?
See, that's where, as I said, as in, first of all, the digital boundary is required, right? As in, that's where the initiative has been taken by the government. That's one part. But now, how we work with our client, as in, those are the people who are providing us that information. As in, if there is a particular land, right? Who is the owner? Whether if there is an owner or is the tenant farmer, right? That's one thing. So that information is coming back to us. Our job is what we are doing is for that particular farm, whether how many different types of crops are available, uh, what's the performance, different kind of analytics that we are generating. But as you rightly said, as in when you look at India, right, there are different uh, agro agroclimatic weather pattern that you can see if you look at southern India, if you look at northern India, that way. So that's where even when we try to derive any analytics, there is a local information that goes into the algorithm, which helps us in terms of the soil nature, right? One thing, different types of farm practices that's happening in the region, and also if there are different kind of varieties, because all this information that we're getting, it's like having a partner ecosystem who's giving you the feedback to improve the algorithm, first of all, and give them the better insights. So it's like a partner ecosystem. We have a partner ecosystem, and they're providing the ground truth information to us, and that's kind of getting fed into the model. And how they are doing it, we have a mobile application which helps them, first of all, to capture those ground truth in terms of images, in terms of any other information they would like to give us, right? Whether crop type, crop damage, if it's happening, what's the soil type, all those things, which eventually helps us also to improve the algorithm, also to validate our model on a continuous basis. And that's how, because as Ajay also has mentioned that in India there's a lot of data, but you do not have a common repository as such. And that's where we are kind of collecting the data, creating the repository at our end to constantly improve things at our end and provide better feedback to our clients. I hope I have answered your question.
100%, sir. Thank you so much. Thank you so much. Appreciate it.
Mr. Banu.
Yes, please. Mr. Banu, can you hear us?
Sir, yes, sir, yes. And good afternoon for everyone, and good afternoon to everyone. Sir, first question to Mr. Rasmil Singh. Actually, sir, there is some technical, means I have some technical doubts, and I also earlier worked in the same technology, means drone-based technology. Here, okay, in most of the crops, most of the field crops in our Indian condition in any ecosystem is almost maturity is comes in the span of same on in the within the 1 month of time. So if you take cotton, if you take some paddy crop, if it is almostly they means Rabi paddy, they almostly they are planted in November. Then the harvesting going to mean in the month of March and end of the April. So how is the what is the practical utility here to utilize the satellite data for the harvesting for bank purpose?
See, as I said, as in they have the financial data, but they do not know what's happening on the ground. So when I talk about satellite data, right, what we are doing is we are giving them 1 month prior to the harvest. And then using the satellite data, you can literally detect where the harvesting is happening, at what rate it's happening in terms of every pixel, right? So that way, that gives them the good indicator. Okay, in this region, there's a harvesting that's going to happen, and this is the performance of that particular region. So they can go and prioritize, and then in terms of collection, whatever the money they have given into the farmer, they can go and recover that. That way, that creates an efficiency for them. Also, it helps to also helps for the bank to identify whether the if there is a damage happened due to some natural calamity in a region, they can kind of uh, create a mitigation plan for that, so that banks also do not suffer, also the end customer do not also suffer. So that's how the analytics can be used, and they're using it for the collection purpose.
Yes, exactly, exactly. But what is my question is, most of the time the harvesting period is almost the same year after year. So how means what is the practical utility?
See, it's almost same, I would say, but it's not necessary that it happens. So what we are doing is we are doing that constant monitoring, meaning on a weekly basis, how much the harvest is happening, where it's happening. So that way they can kind of, there's a time information there, there's a spatial information there. This information they are taking into consideration for the prioritizing. I know what you're saying is like every season or every year, it's happening around the same time. But see, the thing is, every year or every season, one region will not perform similarly to the other region as such, right? There will be some kind of discrepancy in terms of performance as well. That's where this information is essential for them. And most of the fans do not have enough workforce to cater all the agriculture region in India, right? So that's why they need to also prioritize as in terms of the collection process. So this is how they are using the information.
And one more question is regarding this. Some crops like indeterminate crops means maturity means harvesting is a stage where like cotton. So there is a, what is the methodology of yield prediction?
For that we can talk about separately. I would love to have a chat.
Okay. No issue, sir. And,
precisely, sir. We have provided the
yeah.
contact details of the all three speakers.
Sure, sir. Sure. Okay, sir. No issue, sir. And my question to Gopalkrishnan, sir. Yes, yes, sir. Actually, myself is Banat Bhikshapati Naik. Presently, I am working as I am a research scholar in IR, Indian Agriculture Research Institute, New Delhi. Is there any scope to include this whatever your technology? I am interested to include in my research work. So, is there any scope for a collaboration?
Yes, sir. Again, the email is there. So if you want to discuss in detail exactly
Okay.
what that
Sure, sir. Thank you. Okay, sir. Thank you, sir. Okay, sir. Over to host.
Okay, thank you. We'll address one question. Sinu, can you hear us?
Yes, sir.
Please go ahead.
Yes, sir. My query is to Mr. Rashmit Singh. Sir, do we have any solution for counting the plant population on an acre basis or average plant population basis? Currently, we are doing with drone system, but it is a bit costlier. If a solution is available with the satellite, it would be better for us, sir.
Yeah, see, as I said, as in drone provides you better spatial resolution. That aspect is very important when you're counting something, right? Especially the plants, the trees on the ground. Satellite data do provide you that ability when you go for the high resolution data, but still that will eventually be very costly as compared to drone. Example will be if you look at some high resolution data per square kilometer will cost you around $20 for single timestamp. There's no business viable solution for that. So yes, you can do the counting. It's just that there's a caveat. It's an algorithm, right? There will be a limitation to that. And if if the trees or the plants are spread apart enough, based on the resolution that you're using for the identification, yes, you can. But that still it depends on whether you are willing to pay for the high resolution data.
Okay, thank you for that. So before that, we have a question in the chat. We'll take that to Valeria. So there are a lot of Indian farmers on a regular basis visit Israel to know what is the latest happenings there, especially in polyhouses. So do you think any of a cross-border learning, what are the latest developments in polyhouses, can be implemented here in Indian conditions? I do not know exactly what kind of a thing going on here would know, but is there anything you observed these kind of a technology can be adopted?
Well, it's hard to answer for me because, Israel as well as Netherlands probably are the countries where a lot of novel technological things are invented for greenhouses, because they are very popular here and there. And well, there is nothing particular I think that I could mention, but I think that it might be definitely interesting to look at some reviews or market overviews about what's going on in these two countries to be inspired in development for India.
Okay, thank you. Any other participants are here? Okay, you can raise their hands. Meanwhile, we are happy to inform you that Manage has come out with their next call for applications and archive Raftar program. So the application form is live now, where each and every startup, Indian startup, can get an opportunity to fund up to 25 lakhs. We are already at MVP stage, minimum viable product with a possible revenue model. If you're at idea stage, you can get funded up to 5 lakhs. The application form is live now. The link would be provided in the chat. You can go through it. you have any doubt, you can contact us at any point of time to take it forward. And we have Mr. Zakir Hussain raised his hand. We can ask him. Mr. Zakir? Kaushik, can you please unmute him? Mr. Zakir. Zakir, can you hear us?
Yes, I'm able to hear. Can you hear me?
Yes, sir, please.
Yeah, I have two questions. The first question is related to the banking sector, the tools and techniques that is used. Because when a system or when IoT tools gives a green signal to a bank to lend a loan, what is the risk percentage that is the optimal one for giving a green signal to loan? Or even we can take that same green signal based on the environmental factors that it collect and process the things. So this is the first question. The second question is, when I have a local management system to best optimal way that I can control all my disease and other things in a local management system, why do I require a IoT tool or a artificial intelligence or the business analytics tool to improve my performance? So what way it will help me? Because already I am doing it in the right way so that I have a better profit and other things. So how it is helpful for consistently I am a profit making with the local management system that I have. So how it will help for my farming and other things? That is the second question. Is my question is clear?
Rashmit sir?
Yeah.
It was meant for you, sir, please.
Yeah. See, sir, as in coming to the optimus risk percentage as such, it depends on the bank itself, meaning one bank will have a different percentage of the green signal. See, in the end, it's not just our data that they're using our data as well as the delinquency data or the financial data they have at the end. So they're kind of combining it together at the end and coming up with the percentage at which they want to lend. Right, that's one. What we are doing is, as you rightly said, as in your question, that we are taking different environmental parameters. What it does is it gives them the better understanding of things, meaning whether the loan process that they want to initiate, or what should be the basis of that if the particular farmer do not have some kind of history behind it in terms of finance. That's where we are taking into consideration the different aspect to that, like the performance, with what crop he has sown, what was the potential revenue that he could have generated, right? So these are all the elements that they are taking into consideration for making the decision first. Second is, as you rightly said, as in if you have a local management system, you can use like directly use the data at your end. But the thing is that when you talk about the satellite data, it's more of a large area analytics, a large area that you're trying to monitor, right? So it depends on, frankly, the business entity, how what the portfolio is. As in the larger area, that means you can go for the satellite data. But when it comes to the smaller area, as you said, for like maybe 1 hectare farm, 2 hectare farms, and then that's where the drone technology, the IoT technology is more efficient enough to do that. But satellite data provides you a brief overview of a region at a pixel level, but that's where you want to integrate different other kind of data to uh, increase the efficiency in terms of the analytics that you're generating. Meaning, your satellite data can be combined with the drone analytics as well as IoT analytics. It's kind of creating a complete structure here. Then when you have a top to bottom approach.
Yeah, thank you.
Yeah.
Any further questions? Anybody is there? Otherwise, we can call it. Yes, please. Kaushik, anybody else is there?
Omkar.
Hello, sir. Hello.
Yes, sir. You're audible, sir.
My question is to Valeria ma'am. Ma'am, as you have chosen a biotechnology as your field, and I am also from same field. I had chosen agriculture biotechnology, and I am a student of first year. When I see to the future, uh, I'm dreaming to the future. I don't have clear vision about biotechnology as a career. I don't have a clear vision that the biotechnology has a scope in India. Is there is a scope in means biotechnology has a scope in the future?
Do you mean biotechnology for agriculture in particular?
Can you repeat, ma'am?
Do you mean biotechnology in agriculture, right?
Yes, ma'am.
No, I think that you're a bit wrong. I think this is a huge actually market which is very, very much growing because you know, all the genetic editing and the field of making food more efficient and making food of new I don't know, to create food of some new products. This is very interesting and emerging market. And you know that there is like the amount of people on Earth is growing faster than we are learning to use the planet and our like the existing crops in a more efficient way. And I believe that a lot of really interesting things are going on, maybe not even that much in ag tech, but more in food tech, like something that is interesting to look at. For me personally, I'm a big fan of everything that is related to artificial meat, for example, and this is really boosting market. If you read about the company called Beyond Meat, for example, this is the company that did IPO last year, and this is I think the most successful story of bringing agri-food tech to the large global market, and this is absolutely biotechnology like a story. And all the companies that go even further than that, not making a plant-derived meat, but meat created in the labs. I have several friends of mine who have companies like that, and I think that this is crazy and this is very interesting. So yeah, I think that if you study like what can we do to make food more efficient, more ecological, more ethical, there is a lot of really interesting things going on in that zone, and this market is just growing and growing because currently we have like happily the possibility to think of how exactly we create food. Is it good like for the planet, for the people? Like, is it the right way to proceed? And here technologies play a huge role in making things more right. So for me, this is a really inspiring story, and I don't think this is boring, and there is nothing to do in biotech for agriculture. Food tech.
Okay.
Thank you, ma'am.
Thank you. Thank you. We'll take one more last question before we conclude. Mr. Rajneesh Sharma, can you hear us?
Yes, hi everyone. This is Rajneesh. By profession, I am in market research background, and by education, I am from the geospatial background. So I'm working with the market research company, and there mostly product I have seen there are for only for the urban area, like, but I want to replicate the same type of thing for the rural area, right? So what they are doing here, we are just integrating geospatial technology with the socioeconomic data, and then we are doing some type of forecasting and the product modeling and all. So this is so I want to replicate the same thing here for agriculture, but the thing is here, I don't have any, because this is the idea only, but I don't have any funding with me. So because what kind of support manage can give me, because this is just a idea. I want to make it as a POC, but I need some time. I need some resource as a fund. I can do it myself. We are the team of 4 members here, so we can do it. But the problem here is for funding only. Hello.
Yes, sir. Your
I'm
question
audible?
meant for whom, sir?
Sorry.
Your question meant for which speaker? We have 3 speakers here.
My question is only for manage.
Okay. So this is not a simple question to answer in a single line, but what we can tell is we've been supporting various ecosystems at various stages. I think Gopal is the best one to answer because I would rather have it done from our startup rather than me. Gopal, could you please answer that as a startup supported by managed ecosystem, please?
His question has to be slightly more specific, but I'll just talk about how managers help us to frame some of our thoughts and also try to filter out. Sir, we got in touch with Manage last year, and that's when we went through the entire process of application. And during that process, we were also connected with various stakeholders in the Indian agri ecosystem, because we all come from an technology background. And while we are motivated to bring in, technology into the space of agriculture, unless and until you don't go and do the work on the ground, toil on the ground, there is no way that you'll be coming out with a success story, or in terms of scalability will always be a question mark. That's where managed helped us to quickly connect with, say stakeholders, whether it is direct farmers, agribiz organizations, FPOs, connections, to kind of get our use cases not only in one given area, but like how do you multiply and different use cases can be derived. So I think that was one great benefit of getting connected with managed. Second is they have connections with the different stakeholders, government, which plays a key role in the field of agriculture, right? So how do you connect with them? How do you put across your thoughts to them? Then for our business case, how do we refine our business case for fit into different segments? So these are all the benefits, all the way from thought process to refining to also getting the funding, because you need to have some what do you call handholding when you're at like your early stage where you said it's an idea but you don't have funding. Manage will be a great candidate for you to help you in that handholding during your initial stages.
Sure.
Thank you
sir.
for explaining your journey. Rajesh sir, we have shared our number also directly to you. You can call us. We will be able to help you and on one-on-one basis, we can help you and how we can take it forward.
Sure, sir. Thank you. I got it.
Anything else you would like to know, sir? Rajnish sir, can you hear us?
Yes, I got your number, sir. Thank you.
Anything else you would like to me to address in the public forum? Please let me know. We are ready to address that.
No, sir. It's over from my side.
Okay, thank you very much. Would like to thank all our 3 speakers today, Valeria, Gopal, and Rashmika sir. Thank you, Rashmit sir. Thank you very much. Would like to thank our Director General Manage and our Director Sir Dr. Sharon Raj, Agriculture Extension, and CEO for Center for Innovation and Agripreneurship, and all our entire CA team, and all our last but not the least, all our attendees, our participants, without whom it has been not this much. We have come this far. We're happy to know that we'll be doing our 50th webinar in the next week. We have completed 49. We'll be doing 50th next time. It's been huge response from, we have close to 25,000, 23,000 plus registration so far. So we look forward to your presence at our next 50th one, which is on soil, how the soil testing has been done and what are the latest technologies that are there. Thank you very much. Please stay safe. We'll look forward to seeing the next week. Thank you very much, sir.
Thank you.